Welcome to CS284 Module 6. I'm your instructor, Robert McMillen, and we are going to talk about network devices. So, security dependent on understanding on basic network device functionality. You need to understand what a hub is versus a switch versus a router. Now, we don't really use hubs much anymore. Matter of fact, they're very difficult to even find. But if you look at the OSI model, that is the 7 different layers of how data travels from one computer system to another, you'll see that the very bottom level is the hardware level, and that is where the hub and the network interface cards actually live. Now, of course, we still use NICs on all of our devices, both wired and wireless, but hubs not so much because they tend to not have any intelligence to them, and they broadcast a lot of information over and over, as we talked about in previous modules. So at the next layer up, the data link layer, is the switch. Now, the switch does have some intelligence. It tends to not forward on a lot of broadcast traffic which can be used by hackers in order to grab packets and then look at data that they shouldn't be looking at. However, if you have certain types of MAC flooding, then you can then cause a switch to turn into a hub because you've used up all of its buffer types of memory that it uses, and then it ends up losing that intelligence and turning itself back into a hub, which we certainly don't want to happen. At the next layer up, we have a router. Now, a router runs at the network level of the OSI model, and that is layer 3. And the router itself separates traffic from one subnet to another. And of course, all 3 of these devices can be compromised, and there's various different ways to do that. So MAC flooding we talked about with the switch. There's also impersonation, where a switch is hit by two devices with the same MAC address. So one MAC address is burned into the hardware device of a network interface card, but you can use another type of software on another device which impersonates the MAC address of the first one. So what'll happen is the switch, it depends on the type of switch. In some cases the switch will just freak out and then it won't send any data at all. But in other cases, depending on the switch make and model and revision, it will send the data to both of those devices. And if it does that, then of course the attacker can get any information that was designed to go to the valid computer, and it would go to his invalid computer while he's hacking the systems. Another type of vulnerability is ARP poisoning. And this also has to do with MAC addresses. Basically, an attacker sends a forged ARP packet to the source device, and then it substitutes the computer's MAC address at that point as well. Now, port mirroring and network tap, which is test application point, those two are generally used by administrators in order to monitor a network. So port mirroring is a type of port that you turn on a network switch, and what it does is it mirrors either one or all of the rest of the ports of the data that's passing through it, and it allows you to plug in a device that basically monitors all the traffic going on all the other ports, and so that can be very helpful. A network tap is similar, except for it's an outside device, and it's basically monitors traffic between 2 devices. So you put this between, say, a switch and a router, or a switch and another switch, and all traffic that passes back and forth is then sent to a monitoring system to see what's happening on the network. Well, those can also be used by hackers and attackers as well, because if they are able to get plugged into one of the mirrored ports, and then they're able to turn that on the switch, or they get access to a network tap and put it in, and you're not aware that it's there, and of course they can intercept all of the traffic that's going on, and then they can perform all types of man-in-the-middle types of attacks. Let's talk about firewalls for a little bit. There's several different types of firewalls that are out there, and the firewalls also provide a couple of different ways of protecting you. The first way is based on access control lists, and it's called stateless type of packet passing. So it either allows or denies traffic based on various different protocol rules, such as, is this an IP address that we're allowing in? Is this a source that we're allowing in? Is it have a destination that we're allowing in? And either allows or denies traffic, based on that kind of information, such as, let's say we're allowing all IP addresses to come through on port 80 to our web server, so that way they can look at our website. Well, that's fine. So if they try to come in on 80, they're allowed through. But if they try to come in on another port, such as port 81, then of course they are denied. So that's a basic stateless type of access control list that's built into all firewalls. They also have firewalls that now have stateful filtering or inspection, and stateful inspection is used more from the inside out. So if you are a user on the inside of a firewall and you want to go out to a website, then you'll do stateful inspection, and this does work both ways as well. But a lot of times companies will use the stateful inspection in order to protect their inside devices. And so it will create this three-way handshake. So the first part of that handshake is you go out to the device acknowledges you in the second part of the handshake, and then the third part of the handshake is the data is now passed. That's stateful inspection. So this three-way handshake is kept in a database or in a table for a certain amount of time, and once that time reaches its expiration due to inactivity, then it just drops that stateful inspection connection, and then no data is passed until a new three-way handshake is then established. So that is a good way to keep people from spoofing addresses and things like that, because if they say they're from a certain address and it turns out they're from a different address, then that three-way handshake will not actually take place. And application firewalls are another good way to filter out unwanted content going in either direction. It does in-depth scanning of content. So as we talked about earlier, the firewall is also a router, and it runs at the layer 3 of the OSI model, which is the networking layer. Well, the application layer is all the way at the top. It's at layer 7. And an application firewall will look at not the packets of data at the IP level, but it'll actually look at what's in the data itself. It can do in-depth scanning of content filtering to see whether or not it's got a virus in it, or whether or not it's data that we want to get passed through our network. A proxy server is a different type of firewall. And actually, proxy servers came around before stateful inspection firewalls, but they turned out to be too slow. But the good thing about proxy firewalls is that they offer the highest level of firewall security. So what happens in a proxy type of a firewall is a connection comes in, for instance, from the outside, say to your internal web server. When the connection comes in, the proxy firewall takes that connection and breaks it, then creates a new connection between the proxy firewall and the web server itself. Once that data is returned to the firewall, then it breaks that connection, and then it creates a new connection from the firewall back to the user. So this happens constantly between the user and, say, the web server, with the firewall in the middle, proxying all of the connections. So one of the reasons why it's so secure is because of the fact it breaks the connection. So any type of hacking will get broken before it even starts. So the bad side, of course, of that is that it's just too slow. And so that's why we moved from proxies over to the content filter, or to the stateful type of firewall, except for some things like content filtering and some other types of things that it just makes sense to use proxies even though they are slower. So there are certain types of times where a proxy server still makes sense for firewalling or caching and doing other things like that. But there's other times where it's just too slow, so we use stateful inspection instead. Let's talk about intrusion detection systems and intrusion prevention systems. They constantly monitor network traffic. These devices can be software packages installed on a firewall, or they can be third-party products. They could also be installed on your endpoints, such as your computers or your tablets, etc. So intrusion detection is different from intrusion prevention because intrusion detection uses signatures. So it uses known attack signatures. So if it sees a known attack attack signature that's out there, and there are thousands of them out there, then it'll say, hey, I recognize this traffic and I'm going to stop it, or I'm going to alert somebody that this signature is coming at me and it's trying to attack me. Very similar to, say, a virus signature, except for this is more of an attack. An intrusion prevention system is a little bit different. It uses heuristics or a fuzzy logic, and it says, hey, I don't know what this is, but it's not normal for my computer. So the first 2 weeks, say, for example, of the life of an email server, an intrusion prevention software agent is installed on the email server, and it looks at the type of traffic that is normal. So it's in learning mode for the first couple of weeks. And then after that, it goes into its IPS mode. And if it sees some sort of traffic that is not normal for that particular mail server, then it uses its heuristics in order to stop any traffic attack coming from a hacker from either outside or inside the network. So it's actually useful on the inside as well in case an attacker or an employee decides to go rogue to attack something internally. So they both detect signatures and protect using the heuristics types of logic. Network access control. This is another name for the network access protection that we're using in the Windows 2008 server that we talked about in previous modules. So it secures your network by requiring authentication to access the network. Of course, you have to have two-form authentication, something you have, something you know, and then it does a health check. So once that health check gets started, then basically it says, hey, is your antivirus up to date? Are your Windows updates running? Is it set to automatic, and are you up to date? And it runs through various different health checks to make sure that the computer is going to be safe before it's allowed onto the system. And you can do this both internally or externally through VPN users, for instance, or both. You can have the health checks be run on all devices if you want. Of course, that's a really good idea, but it does tend to annoy people because of the slowdown, and especially if they don't pass the health check. So you have to weigh those annoyances versus the benefit of being protected against various different types of malware and other attacks. So that concludes our Module 6, and we talked about network access control and other types of network security.